This is the best self-working card trick ever created. If you only have time to learn one trick and you want that trick to amaze everyone, and that trick requires no sleight of hand, this is the trick you should learn. So as you can see, the magician would have a prediction on the table, and this will remain in sight the entire time. The magician would then open the box of cards and cleanly take out the deck. He would then spread out the cards and show the spectator that every card in the deck is different. And actually there's a couple of jokers in here which we don't need for the trick, so I'm just going to get rid of these now. And then what the magician would do is split the deck roughly into two piles, and then the magician would take one pile for himself. So let's say I will take this pile here, and the spectator will take the other pile. The magician then tells the spectator that he's going to do a few things and he just wants the spectator to copy him. So firstly, the magician takes his pile and mixes up all the cards as much as he likes. So the spectator takes their pile and also mixes up all of their cards. The magician then says, I'm going to take half my cards, flip them over, and give them to you. So the spectator takes half of their shuffled cards, flips them over, and gives them to the magician. And then the magician instructs the spectator to do what he's doing, which is shuffle them face up into face down. So that's exactly what the spectator does. He shuffles up the cards face up into face down. Everything is squared up, and then the magician says, let's do this one more time. Let's take half the cards, flip them over, and the spectator does the same thing, and then mix them up. So the spectator and magician both do this, and then the magician says we're going to do it one last time. So I'm going to take a random number of shuffled cards, flip them over, and the spectator does the same thing, and they mix up all of the cards. Now you must agree that everything that's going on here is random. The spectator and magician can choose as many cards as they want to mix up, and everything is just clean, fair, and random. The magician then takes back both piles and says he's going to mix both piles together like this. Really burn this image into your head, as you can see that all the cards are genuinely being shuffled and mixed together, and there's a random number of face up and face down cards. I'll show you this side of the deck, and I'll also show you this side of the deck here. So as you can see, everything is random, and the spectator agrees. But the magician then points to his prediction and says to the spectator that on the underside of the prediction, it says there will be 25 face down cards. The spectator looks confused because they shuffle the cards, they both chose how many they flipped up, how many they flipped down, yet when the magician picks up the cards, he cleanly counts them off one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So the magician's prediction was correct. These cards are then placed to the side or off because they're not needed, and then the magician opens up the prediction one more time and says, I didn't stop there. I also predicted that 10 of the cards will be black cards. So the magician turns the cards over and counts out the black cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, the magician is correct, and the spectator's mind is blown. But the magician then says, look, I didn't want to stop there, because if we open up this prediction one more time, it says all of the cards will be clubs. And the spectator splays out all the cards, and he can clearly see that every card here is a club. All of these different cards are clubs. But then the spectator points to the ace of spades and says, there's one card in here that isn't a club, and the spectator thinks the magician has got the trick wrong. The magician then opens up the prediction one more time, and inside the prediction is a folded up card. And in this card, it says, except for the ace of spades, the spectator is fooled.
Okay, the effect that you just saw, which is called shuffleboard, was created by Simon Aronson, and it is a great example of how a very simple mathematical idea can be used to create mind-blowing card magic. So what we're going to do here is we're going to empirically kind of verify what's going on so that you understand, oh, I can see why it works. And this will enable you to not only use the principle more confidently because you'll know what to expect, but it will also give you ideas for how to use it in different situations and perhaps how to even branch off from this core idea and come up with your own principles that could be used in mathematical card magic. Now, one of the challenges in clearing away the complexity of what went on in that presentation is we need to not become overwhelmed with the color of the faces of the cards. Some are red, some are black. Some of these were in the spectators pile at the beginning, others in the performers pile, and then we're flipping things over, face up, face down, moving from one pile to another. It's really easy to just find the complexity of all of that mind-boggling, which adds to the surprise at the end that anyone could possibly predict the ending organization of the packet. So to help us reduce the complexity of the presentation you just saw, what I've done here is I've chosen red back cards to have red faces as well. So if you see this card face down, you'll know automatically that the face of the card is also red. I've done the same thing with the blue back deck. So if you want to think of this as black, I guess, or B for black, the face of these cards will be black. Okay, so if you see a blue back card facing down, you know that its face is black. Okay, so that will help quite a bit and improve our chances of not becoming overwhelmed with the visual complexity of red face and black face cards being flipped and transferred and then flipped again and then transferred yet again and so forth. Okay, so that's why I'm going to use cards from two different decks to help us. Okay, so the principle at the heart of this effect, I call it the FOAT, F-O-A-T principle, or the F-O-A-T procedure, okay? And that stands for flip over any number of cards and transfer them. Now, many procedures, like this one, have something called a mathematical invariant. So this is simply some kind of characteristic or property regarding the packets that's unchanged despite the number of times a certain procedure is performed. So here is the property that doesn't change regarding these two piles. So given any two piles of down-facing cards, call one pile the spectators pile and the other pile the performers pile. Any number of applications of the FOAT procedure will preserve the following property. Okay, so this is what we're going to kind of explore and informally verify together here. The spectators' original cards will always face the opposite way to the performer's original cards within each of the two changing piles. So the thing to do is think of the performer's pile as consisting of just red cards, which is what I'm doing here. And think of the spectator's pile as consisting of just black cards. Now, in the actual presentation, that's not true. We have red and blacks mixed in, which is just muddying the waters quite a bit. And that's why people can't see through the chaos of the whole thing. Okay? But this will enable us to clearly see, oh, okay, what really is going on here? Okay? So the first thing I want to show you is if I take, so just think red cards are the performer's original cards, regardless of what pile they get moved to, and the blue back cards are the spectator's cards, regardless of which pile they end up in or get moved to, okay? So for example, if I want to move just the one card here to the spectators pile, the way that it's done within this routine is you flip it first and then you kind of mix it in. So we'll just put it up there for now. So whether it's mixed in or not, the important thing is look at the state of the cards. Is it true that the spectators' original cards, which are these blue backed ones here, do they face the opposite way to the performer's cards within that pile? Well, they do, because the spectators' cards are face down, the blue ones, and the performer's card, which is a red face card, is face up. Okay, so that indeed is the case. Okay, now as you might imagine, if we move a card from the spectators pile, remember when we move cards we have to flip them first. Okay, that's really what the procedure was. This new pile will also satisfy that. Is it true that the spectator's original card or cards, well, this is the only card the spectator originally had, and it's sitting right there. Is it true that it faces the opposite way to the performer's original cards that are in that pile? Well, yes, for the same reason. The performer's cards are facing down, and the spectator's card is facing up. Okay, so what we'll find is it doesn't matter how many cards are transferred, and you can do this many times back and forth, this property here will hold. Okay, so that's why it's called a mathematical invariant. This will always be true given this procedure of flipping over any number of cards and then transferring them to the other pile. So for example, if we now take 2 from the performer's pile, flip them over, and then set them on top of the spectators pile, it is still the case that the spectators' cards, namely the blue ones, are facing the opposite way to the performer's cards. Okay? Now it gets a bit more interesting now if we go back and maybe we'll grab one of the spectators' cards, all of these, and then flip those, which is what's required, right, to move them. Okay? Is this property still the case? Well, it is. The spectator's original cards, which is just this one here, this black one, it faces the opposite way to the performer's original cards. Okay? And if we were to move another one of these over, we flip it and set it down, that will still be the case. Spectators' 2 cards here face the opposite way to the performers. Now if we take all of these here and flip them and set them down, is it still true that the spectators' original cards, which are just the blue back cards, are they facing the opposite way to the performer's original cards? They are indeed. So it doesn't matter how many times you go back and forth, as long as you're flipping them before you set them down on the other pile, this will always happen. It will always be the case that if there are spectator and performer cards within a given pile, they will face the opposite way to each other. Technically, it doesn't matter which pile you flip at the very end. You're going to finish with a packet that satisfies this, namely, the performer's original cards will be facing the opposite way to the spectator's original cards. Okay? And so the only thing the performer needs to watch for this final step is they need to know which cards they want facing up and which cards they want facing down. So if they want the cards from their original pile as the performer to be face down, then this is what they would want right here. If they're wanting the spectator's original cards to be facing down, then we should have flipped the bottom pile on top of the top one, and we would have arrived there. In fact, we would just arrive here. You just flip them, right? Okay. And then the rest of it, it comes down to the construction. So the performer set up one of the piles, let's say his pile, in a special way. So you construct a pile that has the characteristics that you want, and those are the very cards at the end that agree with the written prediction, and then the other cards don't even really matter, the other pile. Okay? So that really is the secret to it. There's this underlying mathematical invariant that guarantees that this bottom statement will always be true at any stage in this procedure or process. And then the final step is you flip either the top or bottom pile so that the cards that you want face up are face up. I hope that's helpful for some people to really see what's going on. So thank you for watching, and take a look at other videos on the Absolute Math Magic channel.